Good afternoon, and thank you for joining us today. I am Linda Coyne, and I am the Media Opportunities Manager in the Research Department at SKC. If you have any questions, please submit them on the sidebar or on the right-hand side of the screen. We will answer your questions at the end of the presentation. With me today is Lucinette Alvarado, Technical Services Manager and Corporate IH for SKC, Joseph Elder, Media Lab Coordinator for SKC, and Chris Golo, Vice President of Quality and Responsible Care for Anderson Development Company. Just a little background on SKC. SKC was incorporated in 1962 and is a privately held company with about 150 employees. We have been a leader in air sampling technologies for over 55 years in the field of industrial hygiene. That work mostly concentrated on sampling for vapors and particulates. On July 15, 2019, SKC acquired Colorimetric Laboratories. SKC was interested in the dermal market and felt that CLI would be a good match with our current product line of vapor and particulate products. As we all know, more than 60% of chemicals used today have skin notations. I'm not going to talk too much about the toxicity of MOCA, but just a few details that MOCA is a non-volatile chemical, and thus dermal exposure is the primary exposure route. MOCA has a skin notation, and thus it alerts health and safety professionals that air sampling is insufficient to accurately assess the exposure. Today, we will be talking about some of the SKC dermal sampling solutions for MOCA, and those include the surface swipe, skin swipe, PERMEA-TEC for gloves, D-TAM skin cleansers, and decontamination surface solutions for aromatic amines. The outline for the video demonstrations are the surface swipes, and then the decontamination of surfaces, skin swipes, the PERMEA-TEC indicators for gloves, skin cleansers, and sample preparation and analysis of urine samples for MOCA. Surface swipes are approximately 1 inch by 1 inch in size and contain a treated sorbent pad that can detect MOCA. On the back of this pad is a plastic tab that makes for easy wiping of the surface. And so you spray the surface with the developing spray to enhance chemical pickup and development of color. Wipe the surface with the SKC swipe, and then let it set for 3 to 5 minutes. Observe if there is a red-orange color development. If there is, MOCA is present on your surface. Just as a side note, SKC has conducted some recent studies and has determined that 5 micrograms of MOCA can be detected on a surface swipe. These are some of the decontamination solutions that we have for MOCA. They're usually a combination of 2 solutions, cleaning, developing, and decontamination. It is very important that not only we detect the decontamination on the surface, but we have to have ways of removing it from the surface. So first of all, we wet the area thoroughly with a cleaning developing solution, and you can use an abrasive pad if necessary to enhance penetration. Then you spray the area with the decon solution and wait at least 15 minutes. Rinse with water. Recheck the area with a surface swipe to verify decontamination is complete. If color develops on the swipe, repeat the steps until the area is clean. Wear gloves always when decontaminating the area. Now for tools, it's a little bit different, and so you mix 1 part of the DECON solution with 3 parts of the cleaning developing solution and place that in a closed container. Put tools in the container and let them soak for 5 minutes. Take the tools out of the container and rinse them with water. Recheck with surface wipes to verify that they are clean. And now we will start our video. Okay, where is it? Wait at least 30 seconds for the chemical to be dissolved from the surface. Wipe the area with the aromatic amine surface wipe. We then will let the swipe set for 3 to 5 minutes for the color to develop. The swipe will begin to turn red if MOCA is present. Here are some side-by-side comparisons where you can see at the start there was no red color, and after 3 to 5 minutes at the end, we definitely have the red color for MOCA. Next, we would like to begin the decontamination of the surface where the MOCA was. We again spray on the cleaning developing solution, and we scrub thoroughly with an abrasive pad. Next, we spray on the decontamination solution for aromatic amines. Allow the decontamination solution to react for at least 15 minutes. We are just doing 5 for this demonstration. Rinse the surface with water, and then dry the surface with a paper towel or a cloth to remove the water and the decontamination solution and the MOCA. Now we'll be rechecking the surface for MOCA contamination. Again, lightly spray the cleaning developing solution. Wait at least 30 seconds, again, to get good removal of the MOCA from the surface. Test the surface again for remaining contamination by using an aromatic surface swipe, aromatic amine surface swipe. Wipe the area. Let the swipe pad sit for another 3 to 5 minutes. If no color change is observed, then the surface has been properly decontaminated. If the swipe turns red again, repeat the decontamination steps. Oh, I don't know if you want to do that. Next, we will move on to skin swipes for MOCA, product number 7691031. The skin swipe has two parts to it, a detection pad at the top of the swipe and an untreated pad for wiping the skin. The detection pad contains the same chemistry that is on the surface swipe. The reason we do not use the surface swipe to wipe the skin because it is treated with chemicals. So the procedure is to wipe the skin area with the cloth portion of the skin swipe pad. Pour 1/4 inch of the cleaning and developing solution for aromatic amines into a small cup that is provided in the kit. Place the skin swipe pad in the cup, cloth end down, and color detection strip up. The developing solution will wick up to the color detection strip, and a color change will occur if MOCA is present. And now we will get ready for the skin swipe video. So here we are getting ready to swipe the worker's skin with the cloth portion of the skin swipe. And as you can see, there's a plastic cup in front that contains the cleaning developing solution. We will then place the cloth end of the skin swipe into the developing solution. For this demonstration, a separate skin swipe has been spiked with MOCA. Let the skin swipe sit in the cleaning developing solution for 5 minutes. The developing solution, along with any contamination, will wick up through the white pad and into the detection pad. If MOCA contamination is present, there will be a color change to orange-red. And as you can see, it's colored on both sides of the strip. Next, I'd like to talk about PERMEA-TEC sensors for MOCA. Chemicals can permeate through the skin, and thus we wear protective equipment such as gloves. In the workplace, gloves can be subjected to repeated flexing, abrasion, and stretching. The PERMEA-TEC sensors are like small bandages, but they contain a chemical detection pad on the outside, which will detect the presence of MOCA. It is recommended that when you are testing a new glove under work conditions, that you use the double glove technique, where a glove is placed on the hand, the PERMEA-TECs are then placed on this first glove, and then a second glove is placed on top of the PERMEA-TECs. The skin should be protected using this technique. Test the glove every few hours during the day. So the procedure is affix the PERMEA-TEC sensors to the thumb, middle finger, and palm on the outside of the glove currently being worn. And these areas are selected because these have been shown to be high areas of contact of chemicals. Then you place the glove to be evaluated over the first glove. After 1 hour or 2, remove the outside glove and the underlying PERMEA-TEC sensors. Develop the pad on the sensor by spraying it with the aromatic amine cleaning developing solution. A positive indication of breakthrough results in a red-orange color change. And now we will go to the PERMEA-TEC video. So here for safety, 2 gloves must be worn when testing the MOCA contamination glove breakthrough, just for safety purposes. Put on the first glove that you'd like to evaluate. Then take your PERMEA-TECs and take off the papers from the adhesive part of it and apply a PERMEA-TEC sensor to the thumb. Then take your next PERMEA-TEC and put it on the middle finger. And lastly, apply a PERMEA-TEC sensor to the palm. As I mentioned earlier, these are high contact areas where chemicals can likely permeate. So that's why these areas are looked at. Next, put the outer glove on over the top of the first one and the PERMEA-TEC sensors. At this point, the worker would perform their routine job functions, whatever that might be: opening valves, working with drums, transferring pellets. Again, in this demonstration, the PERMEA-TEC sensors have been spiked with MOCA to simulate glove breakthrough of the contaminant. Remove the outer glove after a certain time period. With gloved hands, peel off each of the PERMEA-TEC sensors and place them onto a clean surface. Spray the PERMEA-TEC sensors with cleaning developing solution. Let the PERMEA-TEC sensors sit for 5 minutes. If MOCA is present, a color will begin to turn red. And as you can see, the PERMEA-TEC pads are definitely turning red. Next, we're going to move on to the D-TAM Skin Cleanser. Just as aromatic amine DECON solutions are important for removal of contaminants from surfaces, contaminants on the skin must be removed as well. It may surprise people, but soap and water do not work for removing all chemicals on the skin. The D-TAM skin cleansers are designed for chemicals that are only partially soluble or insoluble in water. They have been specifically formulated with non-toxic and biodegradable solvents that gently solubilize the contaminants on the skin for later removal by water. It is surprising how many skin cleansers are on the market that contain toxic and harsh chemicals that can actually degrade the skin and promote skin permeation. So to use the D-TAM skin cleanser, you apply the D-TAM directly to the contaminated skin area. Do not use water do not apply water prior to applying the D-TAM. Rub gently the D-TAM into the skin to create a lather. Then rinse the D-TAM from the skin with lukewarm water and dry with a paper towel or cloth. Retest with a skin swipe to verify decontamination is complete. Repeat if necessary. And now we will move on to the D-TAM video. This demonstration will show the process of decontaminating a worker's hand, then checking for residual MOCA with an SKC skin swipe. First of all, take some D-TAM out of the gallon jug and apply an appropriate amount to fully coat your hands. Try to get it into all the cracks and crevices to make sure you've covered all areas of your hands. Then rinse your hands clean using lukewarm water. Make sure you remove all of the D-TAM with any residual MOCA that might be present. Then wipe your hands dry with either a paper towel or a cloth just to remove all the liquid. And then, of course, shut your water off. Then place a cup of the cleaning developing solution on the sink surface. This will be used for the skin swipe that will be used to check for any residual contamination on your hand. Again, we wipe the skin with the cloth portion of the swipe. It is then placed cloth side down into the plastic container with green developing solution. We let this set for approximately 3 to 5 minutes to look for color development. The solution is absorbed into the cloth and it will wick up its way up into the detection pad if it is present. If any MOCA is still present, parts of the detection strip will turn red. In that case, the worker would need to repeat the hand washing process. However, if the detection strip does not change orange, then the worker's hands are free of MOCA contamination. Next, we are moving on to urine testing for MOCA. Technology was developed by CLI Laboratories for analyzing MOCA in the urine. This service was provided exclusively to the Polyurethane Manufacturers Association, and SKC is continuing this service. The sample is prepared by adding solvents to the urine And then the urine sample is extracted on a solid phase extraction cartridge. During the extraction, additional solvents are added which remove unwanted contaminants such as proteins. MOCA is ultimately collected on the SPE cartridge, extracted, and analyzed by HPLC with UV detection at 254 nanometers. The cartridge is extracted into a culture tube where it is transferred and analyzed, again, by HPLC with UV detection. The limit of detection is 15 micrograms per liter per sample. Why is urine analysis important? When combined with surface and skin swipes, it will allow the user to quickly determine where an exposure may have occurred. There were many situations that Tom Klingner from CLI discussed with me where a urine sample came back high and a surface swipe was used in identifying the exact source of the contamination. During the analysis, I just wanted to talk a little bit about the calibration and quality control. We prepare 6 fresh MOCA calibration standards for every group of samples that are received each month. And in addition to that, 2 spiked urine samples are also prepared to check the recovery of the MOCA from the urine. An initial recovery experiment was conducted when we started this analysis a year ago, over a range of 15 to 270 micrograms per liter of MOCA. The average recovery found was 87.2%, which is pretty good. The results for each sample are adjusted for this recovery. This is the reporting sheet that some of you may have seen, where we report the results for the samples. The contact information is on the top part, and then the different sample numbers that go on each urine sample would be on the sheets, and the data would be reported and emailed and physically sent to the customer. So now I'd like to do the final video of the day, the MOCA urinalysis. Okay, as you can see, the urine sample in the plastic container with the identification number. And so in the sample preparation, we take 10 milliliters of this sample, and by using a pipette, and then we transfer it into a 25 milliliter cup, which you can see in the middle part of the screen. Then we add 10 milliliters of 50-50 acetonitrile distilled water to the urine cup, or to the urine sample. We then take the urine sample and transfer it into a reservoir that will be a part of the solid phase extraction procedure. A vacuum is engaged to pull the urine sample through the SPE cartridge, and that is where MOCA will eventually collect on that. The vacuum is then disengaged. And the MOCA is going to be extracted from the SPE filter by using 3 milliliters of 60-40 acetonitrile and buffered distilled water. The vacuum is engaged again, And then the sample, as you can see, is collecting into a culture tube below the SPE filter. The vacuum is then disengaged. And the culture tube rack is removed from the vacuum chamber. The contents of the culture tube are then transferred into a sample vial, which will ultimately be analyzed. So next it's the MOCA analysis, and it's just a matter of transferring this sample into an auto sampler vial. So the sample is drawn from the vial and put into a smaller auto sampler vial. And this carousel you see here, this is usually packed full of samples that we get monthly. So it's pretty unusual just to have a couple of samples. We usually have a lot. The auto sampler vial is then capped, and the carousel is put into the auto injector, auto sampler, and the analysis is started. And basically, this is a chromatogram that is generated, and from these chromatograms, we are able to calculate MOCA concentrations using our calibration standards. Okay, just that is pretty much for MOCA, but I just wanted to also just share quickly that we do have other chemicals that we detect with our surface and skin swipes. In addition to aromatic amines, we look at aliphatic amines, aromatic and aliphatic isocyanates, acids and bases, and phenols. And here is a list of all the different compounds that can be used in each one of these groups. As you can see, there are many, and we're continuing to test to see what, how many different compounds do respond to all of these chemistries. So we're continuing to add to the list. And that's it for today. Thank you for your attendance. And are there any questions?
Thank you, Linda. Thank you for all that great information. That was awesome. Just a reminder to everybody that, we do have some time for questions. And so if you have something that you'd like to submit, please use the chat bar to the right side of your screen, and we'll be happy to do that. Linda, I do have a question here for you that was submitted. It is a question about the swipes. Mm-hmm. The question is, do other aromatic amines besides MOCA give a false positive with the swipes?
Yes, they would. It's not specific for MOCA. So if there were other aromatic amines, yes, they would produce a color.
Okay. All right. Perfect. And can you tell us a little bit more about the process to sign up for the urine analysis?
Chris, can you help me with that? I'm not sure if they sign up through the Polyurethane Manufacturers Association or if they call us directly, but you can definitely call us at SKC customer service, and if you want to be a part of it, we can add you to the list. And then give you the schedule for when samples need to be sent. We have a schedule where we do 2 batches of samples per month, and they're on specific dates so that we can keep the cost of the analysis down. And so we can, if you want to sign up, I would suggest you talk to our customer service group and maybe even Chris Golo, and then we can send you the calendar, and you can start sending your samples in. The way it goes is that we send you a container with the urine samplers in it, so you can you'll have everything that you can collect your sample with, along with labels and other things. So all the things you need to collect your sample, and then you would send that back to us when you're done with your sampling, and then we would analyze it. So
this is Chris Golo from and I just wanted to mention that if a company does want to start urinalysis, contacting SKC directly makes a lot of sense. If they had any questions on potentially some type of testing scheme, so how to develop your testing program, they would be welcome to contact PMA. There's a few people that they could contact. They could contact Mike Kozak, who is my EHS co-chair. They could contact Don Gallo, who's the attorney that works on behalf of PMA, or they'd be welcome to contact me.
That's great. I appreciate that. I think a really nice summary from both Linda and Chris about how to do that. One thing I will mention, Chris said to contact SKC directly. We do have an email address that is specifically for our MOCA analysis customers. And you would be welcome to send questions or any other, anything else that you have. It's SKC MOCA, so SKC MOCA at skcinc.com. And I will make sure that I include that email address and some of the follow-up information that you'll receive after this. So very good. All right, Linda, some more questions coming in here. This is, I believe, a question about the MOCA test. So will aromatic isocyanates like TDI and MDI also give a positive?
I think the answer to that is no. I do not believe that those will interfere with the MOCA analysis, because this procedure was specifically developed for the MOCA. But I would like to investigate that. It's a good question, but I think the procedure is very specific for MOCA because of the solvent extractions and so on. And I do not believe that TDI and MDI, but I will investigate that and get back to you on that one.
Great, that's awesome. And then we have, so a couple questions, again, about the urine analysis. Similar, let me kind of give you both of them, Linda. I think they're kind of along the same lines, okay? Will other aromatic amines interfere with the urine analysis? And then sort of along those lines, are there other amines that can give a false positive in the urine analysis, specifically any medications a test subject may be taking?
Yes, we have had some experiences in the past. I would say we haven't particularly, but CLI had some experience with medications. Yes, that is correct. It could give a false positive. I don't know, what medications we're talking about, but we have heard that some can do that. As far as other aromatic amines, I believe that we would have a chance of separating some of those out, because when we look for the MOCA, we do see other peaks. So I think that that is something that maybe also I can investigate a little further. If you had some specific aromatic amines in mind, that might help. We could actually just try some of those. That would be one of the things I would even do with the MDI and TDI, and see how they, work on that analysis and if they interfere. So, but yeah, I do know there have been cases of people that, take certain medications that they believe it did interfere in the analysis.
I would like to add something about the urine analysis. This is Lucinev, if it's okay.
Sure.
Yes, from a technical standpoint, whenever the specimen is collected, just make sure to follow the instructions, because at times There's instances where the container that is used for the specimen gets overloaded, and that could be an issue because the way it has to be shipped, that may be a little bit of a messy situation. So if the person who's collecting the specimen can talk to the person who will, you know, get the specimen, just make sure to follow those procedures. That will ease the work so much.
Yes, that's a good point, Lucinette. I'm glad you brought that up. Yes, please do not fill it to the top, okay? Because when it freezes, it, you know, expands, and when we open the samples up, they're leaking all over the place. So that's why we changed to some different cups to get a better seal. I think some of you who are in the urine program might know that we actually are using urine specimen cups now. And really, we don't need a lot of sample. As you saw, we only use 10 milliliters. And so if you fill it just really roughly halfway up, or maybe slightly more, that is more than enough sample, okay, for the urinalysis. So yes, thank you, Lucinette, for bringing that up. Very good, good point.
No problem. Thank you.
Excellent, excellent. Okay, Linda, next question. With the urine analysis, what is a high reading? What is kind of that threshold that would cause concern?
Yeah, that threshold would be 100 micrograms per liter. And I believe Chris could, you know, I asked Chris where the number came from, the 100 micrograms per liter. And I guess apparently this is a standard that OSHA in California is using, you know, as a reference. And so basically anything higher than that would be of concern, where you might need to go back and look at the workplace and see where, you know, what that worker was doing that particular day. Chris, would you like to add something to that?
Yes, Linda. That is correct. PMA has kind of adopted the stance that 100 micrograms per liter urine is a good reference point to use. It is the California OSHA standard, and it's the one that the PMA has adopted as our reference point. In talking to a number of processors, you know, Mike and Don have talked to a number over the years. You know, using good hygiene and good techniques, you should be able to achieve significantly lower than 100 micrograms. So, you know, I would consider that the high end. With good practices, you should be able to achieve much lower. And hopefully you can get non-detects. That would be the ideal situation.
Excellent, excellent. Thank you. Another question, and Linda, I think I'll take this one. This is sort of a process check question. So it's, will this PowerPoint be available? And the answer to that is yes. So everybody on this call will receive a link to the recording of this webinar so that you can go back and reference it. And then you'll also have a PDF of this PowerPoint. So you will be able to go back and find this information again. And I will just mention, so for any of you that already participate in our urine analysis program, we will be reaching out to you directly to get your information and see if you'd like to get on the schedule for 2021. So you can be on the lookout for that here in the coming weeks. Okay, and we have another question here, Linda. They're coming in now, Linda. Everybody's got all kind of questions now. When you're doing the urine test, is it okay to have some MOCA detected in the sample, or should you aim for the reading to always be 0?
No, I think Chris just sort of addressed that. I mean, you know, the lower the better, but 0 is probably never possible if you're working, you know, I mean, to be realistic. So our detection limit is around 15 micrograms. So we call that anything less than 15 micrograms per liter a not detect. So I think that you want to shoot for, like Chris just said, in the lower range, like, 20 or 30. I don't want to give a specific number, but yeah, you don't want to like be hitting 90 micrograms per liter all the time and saying, oh, geez, I'm under the 100. That's good. So you should really, I believe, and Chris, you can, further address this, but I think you just did, is that we want to, go for lower level, the lowest levels possible.
This is Chris Golo again, and to amplify that, you definitely don't want to skirt the high end of that, 100 micrograms and remain there. We look at it as kind of a opportunity for improvement. So say you start at a slightly, an elevated level, then you can use investigative tools like the surface swipes. And, a lot of times you'll have an opportunity to either reduce or eliminate, that, or at least get it to a point where it's either very low or non-detect. To try to be as protective of your employees as possible, I think is always a good idea.
Excellent. Thank you for that. Linda, if a person is affected by MOCA, how long would it take to pass through the body, cure from the body? What are we looking at, just kind of the effects wise?
Oh boy, I am not sure of that. You mean the effects of MOCA, or just how fast it can pass through the body?
I can probably answer that a little.
One, Chris?
Yeah, maybe I could answer that. One of the unless you had an extremely high exposure to MOCA, typically it's not. There are significantly worse chemicals, I guess you could say, that you would handle in a urethane shop than MOCA from an acute exposure standpoint. For example, handling isocyanates. In a number of cases, the acute exposure, so the immediate impact could be greater, like say potentially TDI and its relation to potential breathing issues. One of the bigger concerns for MOCA are it is linked to cancer by IARC for its mechanistic action. And there are some animal studies also that link it to cancer. There hasn't been human studies that have found that case. Even though that be the case, you still don't want to have long-term exposure to MOCA, and if you can avoid it, for sure. So I guess the primary concern would is, like I said, that link potentially to cancer. And but yeah, typically the short-term acute issues are are relatively small compared to some of the other chemicals that you would handle. The other thing is it's typically handled in a molten form a lot of times, so you would have the possibility of a thermal burn if you got it on you.
I guess the question I was kind of wondering too is what's like the half-life of it? Does it, once you get it in the body, does it remove itself?
The half-life is relatively short. Okay. It's about 23, 24 hours. So if you do happen to get MOCA, ingested or absorbed, it, basically every 23, 24 hours, that value decreases by half. Mm-hmm. So it's a relatively short half-life.
Mm-hmm.
Okay. Perfect. Well, thank you so much, Linda, for sharing all this information with us here today.
Well, Amber, excuse me, I would like to add something to what Chris said.
Sure.
Okay, the American Conference of Governmental Industrial Hygienists has documentation about MOCA, which if the person who asked the question is more interested, they can go on the site and get the documentation which explains more in detail about the toxicokinetics of it. And Chris mentioned something about the half-life of MOCA, and just to add to it, that's why the ACGIH recommend to collect a specimen at the end of the shift. That way you could get a more accurate reading. That's stated on the biological exposure indices of the ACGIH.
Yes, thank you. That's good. That's good information for our viewers. Yes, thank you, Lucinette.
You're welcome.
Okay, well, many thanks, Linda, to you for your presentation, to our panelists for all the great information that you had to share. And everybody stay safe, and thanks for joining us.
Yes, thank you. Bye-bye.